When our solution consists of a gas or a solid dissolved in a liquid, we're going to need to treat the solute separately from the solvent. So it will be important to understand what a good reference state or standard state for the solute in these types of solutions is. As an example of a solution consisting of a solid dissolved into solution, let's consider a pure ionic solid dissolved into water. The pure solid at 1 atmosphere pressure has a chemical potential of the pure solid, and that is in standard state. The interactions in the pure solid are ion-ion interactions and are very strong. When I dissolve this solid, this ionic solid, into water, the ions become solvated by water molecules and are completely broken apart. So the interactions in the solution are ion-dipole interactions and are very different in strength and character from the interactions in the pure solid. Thus, the properties of the solid change discontinuously as I make the solution. And so it makes no sense to reference these solute molecules to the pure solid because they look nothing like the pure solid. So instead of referencing the solution to the pure substance, we will reference the solute molecules in solution to a given concentration solution. In general, we pick 1 molar as our standard state concentration, although biochemists tend to favor the unit of molality and will often use 1 molal as a standard state. The chemical potential of the solute in solution is equal to the chemical potential of the standard state solute, in other words, the chemical potential of the solute in a 1 molar solution, plus, again, a correction for not being at standard state. Again, this correction term is a function of the composition or the concentration of the solution. Although we've used the example of an ionic solid dissolving into water, you can imagine the same type of argument being made for a gas in solution or any other solid in solution. And so when we have a solid or a gas solute, we use 1 molar or 1 molal as our standard state.